The third method of solving quadratic equations follow the conditions. One, there is a presence of a b coefficient or the term with the first degree of x. And number two, it cannot be factored anymore. This method is also known as the completing the square method, which actually uses the discussion on the previous video, how to complete a perfect square trinomial. Sharing to you right now is the material covering that. So we have four items here, and we are still on roots of quadratic equations, but now we are required to use the completing the square method. As I have mentioned, when we are going to complete the square, we are going to use the concept discussed in the previous video. You might want to check that out. Take a look at the items. For the first two terms of each item here, we actually have the same first two terms as used in the previous video. So again, it's already given there how to complete the square, but still we are going to show it here. So to complete the square, again, it's easiest to solve. It can be factored. When we're going to look at the values here, we have b coefficients 8, negative 12, 4x, and then negative 8x. And then when you look at the fact, if it can be factored or not, be factored or not. So AC way, 1 times negative 5 is negative 5. There are no other factors of negative 5 which can result to positive 8. For 10, no, none of it can result to negative 12. For 1, none of it can result to 4. And 6, none of it can result to 8. That is why we cannot use factoring here. So let us use the completing the square method. And how do we do that? First step. The first step is actually to consider that this constant here will not make it a fact. Well, actually, ito lang. The constant here cannot with this constant here, the expression cannot be factored. So this is the only item that we could actually move out or place it on the other side by adding both sides by 5. So you have x squared plus 8x is equal to 5. Again, we are moving the constant because that is the only item that is not making this expression be factorable. We cannot move the term with x here. We cannot also move here the x squared because these are actually has variables. Okay. Now that we have this, we are going to give here a value for c for this expression so that the left hand side will become factorable, or even it's called perfect square trinomial, which also the same item to be added on the other side. And what would it be? Again, we have the formula last time. You have here the value of c is equal to the square of b over 2 times square root of a, as discussed in the previous video. Again, you might want to check that out. Square. So we have here this formula to get the value of c. And since it's square, we always expect that it's positive. Let's try to check. 8 divided by, let's try, a here coefficient is 1. So square root of 1 is 1. 1 times 2 is 2. So the denominator is just equal to 2. The numerator is actually b, which is 8. So 8 divided by 2 is 4. 4 squared is 16. The value here to be added is actually 16. Same thing, we are going to add it on the other side so that the equation is still an equation. Now that we have this, we can now express this as a square of a binomial. And how do we express this as a square of a binomial? Okay, it's we also have in the previous video a method in determining whether this is already a perfect square trinomial. So let's just skip that one. You might want to get back to the previous video. And how do we make it a square of a binomial? Simply take the square root of the first term, take the square root of the last term, and use the sign of the middle. Of course, when you take the square root of a number, it involves positive and negative. So it should be positive and negative 4. But we are going to use the sign of the second term here. This is actually the square of x plus 4 is equal to 17. Okay. Looking at this process, this actually will use the first method of solving roots, which is actually taking the square root of both sides, which would actually result to just a combination of x plus 4 is equal to, when we take the root, always consider the presence of positive, negative, square root of 17. Okay, then we subtract both sides by 4. So the value here will become x is equal to positive, negative, square root of 17. And then you have here minus 4, which will actually be taken charge by, let's try to use x sub 1 to determine that it's the first possible root, the positive 17 minus 4, and the second, which is actually the negative 17, square root of 17 rather, minus 4. Okay, so these are the roots of the quadratic equation using the completing the square method. Notice the possible roots here, okay? This root and the other one. If we're going to compare this with the previous two methods, we are laid down here by a presence of a radical expression, square root of 17. On the other side, negative, but still square root of 17. This is what will happen if the quadratic equation is non-factorable or cannot be factored. If it cannot be factored, we expect that our roots will contain radical expressions. Okay? Checking for that, I will be leaving that to you so that you could practice also checking. Let us proceed to number two. So number two, this would actually be expressed minus 12x and subtract both sides by 10 because 10 will not make this factorable. So we are going to use the formula here. So a is still 1. So square root of 1 is 1 times 2 is still 2. The numerator is negative 12 divided by 2. So you will have negative 6. The square of it is positive 36. That is what we're going to add here so that our expression will become a perfect square trinomial. You added 36 there. You also need to add 36 on the other side. Then we can now express this as a square of a binomial. Square root of the first term, x. Let's make it closer. The square root of the 36 is positive and negative 6. Again, positive and negative 6. But which is to be used? Look at the sign of the second term, minus 6. So that's the square of it. Is equal to, you have here positive 26. And then from here, you will use the square roots method. And then you will have x minus 6 is equal to, again, positive negative square root of 26 when you take the root of a number. Always consider the positive and negative. You just add both sides by 6. So you have positive negative square root of 26 plus 6. So this could actually be x sub 1. You have positive square root of 26 plus 6. And your x sub 2 is the negative square root of 26. And then you have here plus 6. These are your roots of the given quadratic expression. Again, we expected that our roots will contain radical expressions. They cannot take the value of any rational number, maybe integer or fraction, because the quadratic expression or equation is not factorable. Number three. For number three, we'll use the same formula here. But first, let's move out 1 by subtracting both sides by 1. When we subtract both sides by 1, that will be nullified here. We'll have negative 1 on the other side. And then use this formula. You have x squared, for leading coefficient is 1, 1. And then you have, by the way, when you talk about leading coefficient, when you talk about this value here, we do not consider the other side, okay? We do not consider these values here yet because they are actually already moved out to the other side. So we consider here only this expression to complete the square. You have b is 4. So square root of 1 is 1 times 2 is 2. B is 4. 4 divided by 2 is 2. The square of 2 is actually 4. So that is what the value we are going to add. X squared plus 4x, and you have here plus 4 is equal to negative 1. And then you have plus 4. This could be expressed as the square of a binomial. Square root of x is x. Square root of 4 is positive and negative 2. But which sign will be used? Therefore, the second term, positive. Then you square it. The other side will result to 3. Then we take the root of both sides. Same processes. Don't forget the positive and negative value here. So you have x plus 2 is equal to positive negative square root of 3. And then x is positive negative square root of 3 minus 2 when we subtract both sides by 2. The two roots, the first is the positive. Well, you may also use the first as the negative. Nevertheless, they are both roots. And the second root is the negative square root of 3 minus 2. Okay? Checking again will be up to you. Number 4. Number 4 is again to move out that constant that will not make it a perfect square trinomial by subtracting both sides by negative 3. Subtract negative 3, subtract negative 3, this is what will happen. In the previous video, we already solved for the C here, but let's just going to show it again so that you will actually understand it better. So negative 8, 2, square root of A, which is 2, and squared. So you have 8, negative 8 divided by 2. We cannot simplify this. So you have negative 4 all over square root of 2 squared. Loss of exponents allows us to share the exponent here. So the square of 4, negative 4 is 16. The square of square root of 2 is actually 2. So C is positive 8. 2x squared minus 8x plus 8 plus 8 is equal to negative 3, okay, negative, let's use the red color, negative 3, and then plus 8. Okay. However, for number 4, this is not actually could be expressed as a perfect square trinomial because the first term is not a perfect square. I mean, this is already in a form of a perfect square trinomial, but not yet because the first term here is not a perfect square. Actually, you could just simply factor out 2x squared minus 4x plus 4. So that you would see here the perfect square trinomial is equal to, what do you call this? Positive 5. Okay. So in the previous video, when we talk about completing it as a perfect square trinomial, actually it has a common monomial too. So when you go back to the video earlier, you might notice that it's not yet a perfect square trinomial. I have not shown there that it has a common monomial too. And this is where the perfect square trinomial is. Okay. So why do we express it this way? Because we cannot express this as um, a square of a binomial because again, the first term and the second term are not perfect squares. This one is. So we still need to divide both sides by 2, divide both sides by 2 so that we could actually retain this. So we have x squared minus 4x plus 4 is equal to a fraction form 5/2. Right? And then this is now equivalent to x minus 2 squared equal to 5/2. Take the root of both sides. So square root. So you will have here x minus 2 is equal to the positive negative square root of 5/2. We could actually just express this first into its rational form. I mean, we're going to irrationalize the denominator, that we will not have any squared in denominator, okay? Before moving out the 2. Okay, we are applying the lesson we have learned in the previous grading. So square root of is actually equal to, disregarding first a sign, nevertheless. Then times square root of 2, square root of 2, which is actually equal to square root of 10 all over 2. And that's it. So I'm going to use it here, so that there would be no radical expression in the denominator. X minus 2 is equal to plus minus square root of 10 all over 2. And then you add both sides by 2, you have x is equal to plus minus square root of 10 over 2 plus 2, which could actually be separated by the first term, first root rather. You have the positive square root of 10 over 2 plus 2, or the second term, which is negative square root of 10 over 2 plus 2. If you would like to combine it into just one expression, you may. Take note that 2 is actually 4 halves. This is actually square root of 10 plus 4 all over 2. Sorry for that. Let's increase it a little bit. Over 2. And on the other side, your second root. This is your first root. Second root is negative square root of 10 plus 4 all over 2. So it's a little bit longer because, again, in number 4, your leading coefficient is not a perfect square. Okay, since it's not a perfect square, we need to make sure that, to factor it out to retain the perfect square trinomial, so that we could actually express in this form. And then we have these expressions equivalent to each other. So we expect again that we have radical expressions when we deal with non-factorable quadratic equations, or simply we deal with completing the square method. Okay. So please review this video as you prepare for your assessment later on. But we also have one method that could summarize all methods, even if it has B coefficient or no B coefficient, if it's factorable, if cannot be factored. The last method could actually capture all. Please be excited for that video soon. See ya.